Hello, my dear warriors. Welcome to the final round before your first attempt of JEE Mains. Today's session is all about the high weightage, most predicted, most expected questions, something like sure shot, which you guys were all waiting for. And I have many questions. So it's going to be a good session, more than 1 hour. Stay tuned till the end. And this is Shreyas here, your physics master teacher, who is going to give you the most important, most expected questions for your JEE Mains. And I have been training kids for JEE and for all the examinations that a student prepares for more than 10 years. And I'm very happy and proud to say that many of these kids are doing extremely well in all the prestigious IITs, NITs, BITs, you name it. So let's begin the class. Make sure you smash the like button and also hit the subscribe button. But before we proceed ahead, let me also remind you guys that tomorrow we are going to have a discussion session of the first and the second shift paper. Like you can see, if you're on the home page, you will start seeing these upcoming sessions. So the JEE Mains paper solution, the first shift and the second shift, that's for tomorrow. And then for 25th also will be done, and the remaining days will also be done on this channel. So it's very important that you hit the subscribe button so that you do not miss any of the classes, and also smash the like button so that it gives us that motivation. We are doing this for you guys, so you need to show your love and your support for the channel. Let's begin, guys. What say? Oh, I will share the last session's PDF also. Don't worry, bacha. I'll share it. Ready? Hello Ria, hello everyone. Aisha, welcome. Rohan, Blessy, Naveen, Achiever, Nagraju, Hi Pi. Hello Suchi Mama, DF. Hello Chatvik, hello Crazy. Hello McQueen, hello Naveen. Welcome guys. Nizaf is also ready. Athivan is also ready. Let's begin the session then. All right. So here comes the first killer duper super amazing question on your screen. A solid cylinder rolls down an inclined plane. Height is 3 meters. Reaches the bottom with an angular speed 2√2. The radius of the cylinder must be how much? Let's try this out. So first of all, let me just visualize this scenario. So there is this solid cylinder. It starts from rest, let's say, and by the time it comes down, it has some velocity v. It also has some angular velocity omega. The height by which it comes down, let's say it is h. We all know v is nothing but omega times of r. That's your standard thing. So here is what I will write. The potential energy got converted into rotational and translational kinetic energy. So I'm just going to write mgh, because the question says find the radius, so I'm just going to make some equations, that's all. So mgh goes into translational energy half mv square plus half I omega square. Now this will just become half mv square. Moment of inertia of a solid cylinder is mr square by 2, and omega will be v by r, so it will be v square by r square. If you notice clearly, r square cancels, mass and the mass from here mgh will also definitely cancel. So I'm just left with gh is equal to v square by 2 plus v square by 4. So it is 3v square by 4 is gh. So v square will be 4gh divided by 3. That's what is velocity. So solving it further, v square will be 4 times g is 10. Height is 3 meters, it is clearly mentioned. Height is 3 meters divided by 3. 3 cancels. So v square is basically 40. Rather, v is root 40 meters per second. The question is find the radius. We know v is equal to omega r. We just see over here, because it is rolling, v is equal to omega times r. So root of 40 is equal to omega is nothing but 2√2 times of radius. Root 2 and root 40 cancels, it will become root 20 is equal to 2r. Root 20 is nothing but 2 root of 5. I hope that is clear. And this is 2 times of r, 2 cancels. So r will be nothing but root of 5. That is what it should be. Yes, it is option D. So the concepts involved over here. Number 1, energy conservation. That's the first concept. Second concept, you should know the moment of inertia of any object, be it solid sphere, ring, hemisphere, whatever it is. Okay, you should know the standard formulas for all the geometries. Then the next thing is, because it is rolling, hence velocity of the center is angular speed times the radius. That's the next concept which is used over here. Rest all is simple algebra. Let's proceed with the next question coming up on your screen now. Okay, great. Tirupati, Vadikupla, you can do one thing. I just rewind back the same problem. It's even though it's a live session, and we can always replay back. Okay, so don't worry. Everything is given step by step. I have not skipped any of the steps. All right, cool. Very good, Yashaswini. Let's go ahead to the next question coming up on your screen. In the circuit shown below, find the effective resistance between this point B and this point C. These are also very common questions. Find the effective resistance. Now, usually these kind of circuits happens to be a simple series or parallel circuit. It's just that you should have the eye or the knack to figure out how is this a series or parallel circuit. If you notice clearly, you will realize that if this is point B and if this is point C about which you want to find the resistance, this point and this point is connected by a wire. So these 2 points have the same voltage. These 2 points have the same voltage. Similarly, my dear students, if you look at this point over here and this point, they are also connected by a wire. So they are also at the same voltage. Everybody with me? Lastly, over here, these 2 points are also at the same voltage because they are connected with a wire. So don't you see these two are actually in parallel? Don't you see actually these two are in parallel? These two are also in parallel and these two are also in parallel. All these are in parallel because they have the same potential difference. Same potential difference. Green, red. So potential difference is same. Green, blue, same voltage difference. Red, blue, same voltage difference. So they are in parallel. Everybody gets it? Everybody gets this? Perfect. So now you can just say there is one resistor here, one resistor here, one resistor here. All the three are the equivalent of these two resistances in combination of parallels. Okay. So what I will do is I will just show one resistor here, another resistor here, and another resistor over here. So realize one more thing. This is that green point, this is that blue point, and this is that red point. I have combined both these two resistors into one single resistance. Same thing over here. These two resistance into this one. These two resistances into this one. Everybody with me? Great. Now, what is the value of any of these resistances? Use the parallel formula. Resistance in parallel is R1, R2 divided by R1 plus R2. So R1 is 3, R2 is 6 upon 3 plus 6, which is 18 by 9, which is nothing but 2 ohms. Hence, this is 2 ohms, this is also 2 ohms, this is also 2 ohms. These two are in series. Can you see that? These two are actually in series combination. If they are in series combination, what will I say? You will just show one simple resistor, and this resistor as it is of 2 ohms, and the one on the top, 2 plus 2, will become nothing but 4 ohms. Now 4 and 2 are in parallel. So guys, the effective resistance will be again R1, R2, same formula, upon R1 plus R2. R1 into R2, that is basically 8. R1 plus R2, that is basically 6. So this will be 4 by 3 ohms. 4 by 3 ohms. I hope you can see it. Option C, C for Captain Shreyas. Okay. So PRP, if you cannot remember communication systems, do one thing. I have made a video in the Pathfinder playlist. Just have a look at it. It's probably going to cost you maybe 1.5 hours to 2 hours. Within that time, you will be able to understand the entire chapter. Okay. Great. I am so glad, Bhargav Neil, you are one of my old students and now you are in NIT Warangal. That's so good. I'm so glad that you are doing really well and so happy that you came back to say hello, and probably even the juniors can look up to you, and probably they also get motivated that this channel has helped not just, a student like Bhargav, but also many students who are studying in all the prestigious institutes in and abroad. So thank you very much and keep working, guys. Should serve you like a motivation and inspiration. Next question. The diagram showing the variation of the gravitational potential of the earth with distance from the center of the earth. The gravitational potential and the distance. How will it change? Earth is supposed to be like a solid sphere. So when gravitational potential, basically voltage or potential, is asked with respect to distance for the earth. Earth is basically a solid sphere. For a solid sphere. Now for the solid sphere, the formula is slightly tricky, so you should know that. Solid sphere, the potential is minus, not 3. First I'll put G minus Gm. Here you have 3, capital R square minus small r square. The whole thing divided by 2, capital R cube. That is when you are inside the solid sphere. But once you are outside, it becomes minus Gm by small r. So when you are outside, this is the formula. This is the formula for solid sphere. If it is a shell, if it is a hollow sphere, then this is a constant. It is not a function of r. It is not a function of r, it is constant. So that would be this graph. So this would be for a shell. This would be for a shell where it is basically constant inside. And outside it is basically a curve inversely proportional to r. But if you see inside, there is a r square term. That means it should be a curve. That means it should look like this, a curve inside and curve outside. So this is for a solid sphere. This is for a solid sphere. Hence the correct option should be C again. There you go. Everyone, no prince, it is not B, it is option C. Everyone clear? Everyone clear? Awesome, awesome. Mallo's class, Satvik, don't try to waste my time by asking stupid questions, okay? Concentrate on the lecture. Okay. Hello Kancharla, hello Aditya, hello everyone. Welcome, welcome. Very good. So I am so glad some of you are even keeping a track of your marks, whether it is +4, -1, 0. Very good. If you are keeping a track, that means you are very, very serious and focused. Okay, let's move on to the next question coming up on your screen. All the electrons ejected from a surface by incident light of wavelength 200 nanometers can be stopped before traveling 1 meter in the direction of the field. Okay, and the electric field being 4 newtons per coulomb. The work function of the surface is, will be how much? Okay, so let's try to think. When you apply electric field, what will happen? There will be a voltage difference which will be created. This voltage difference will be created. Electric field and voltage are very closely related to each other. Keep this in mind. That voltage difference acts like the stopping voltage. For those photoelectrons in that photoelectric effect. So we can find that out. It is not that difficult. Delta V, which is also the stopping voltage, will be electric field into the distance that it has traveled. Electric field is 4. The distance that you have traveled is 1. So basically it is 4 volts. 4 volts is nothing but the stopping voltage, not the work function. The question is, what is the work function? Let's try to do this. Thank you so much, Karthika. I'm so glad the lectures are useful. Look at this. Use the photoelectric equation. The energy of the photon is equal to work function plus E times of the stopping voltage. The energy of the photon is 1240 electron volts, you can say electron volts, divided by wavelength. What is a wavelength? That is 200. I hope you know this formula. Energy of a photon is 1240 divided by lambda, if lambda is in nanometers, but the answer comes out in electron volts. Remember that. So this is equal to 5. What is 5? That is the work function. What is the work function? I don't know. I have to find it out. Plus, that is also going to be in electron volts, by the way, in electron volts, plus E into Vs. What is Vs? Vs is nothing but 4. You can see again, this is also in electron volts. 4 was volts. E is your charge on the electron. So 4 volts I have substituted instead of Vs. That's all I have done. Now you can clearly see electron volts and electron volts cancel. And over here also this 0 goes with this 0. 20 goes with 124. 6.2 times. 6.2 times. Hence the value of 5 will be 6.2. Bring that 4 over here, which will make it 2.2. So the work function is basically 2.2. Where is such an option? 2.2. Option D, right? Option D, right? D for what? IIT Delhi. Thank you, Sai Gaming Effect. Nice to see you guys back. Many of you, I'm seeing you after a very long time, and that makes me feel very happy also. Many of you were there during Nurture or even Pathfinder. So glad, and I'm so glad that you have also smashed the like button. Keep it up. Keep promoting the channel. Keep helping all the other kids as well as your batchmates, because the more the people get to know about this, the more motivated we are to conduct more classes like this. All right, moving on to the next next question coming up on your screen. The axis of a solid cylinder of an infinite length, radius r, lies on the y-axis. It carries uniformly distributed current in the y direction. The magnetic field at r/2 coordinate, y, r/2 coordinate is, let's see, how do we do this particular question? First of all, let me draw and visualize. Imagine that the solid cylinder, which is infinitely long, which is placed such that the y-axis itself is the axis. Okay, it looks something this way. So I'm just showing the infinitely long cylinder. Okay, so this is your y-axis. This is your y-axis. Okay, this goes like this. Okay, great. And maybe somewhere below, down over here, maybe there is your x-axis, and maybe coming out of the plane is nothing but your z-axis. Okay, fair enough. So that is your z-axis, and this is your x-axis. Maybe this is the origin right over here. Now the question is, at some point which is r/2, so r/2 is here, y and r/2. Okay, interesting. So this is probably the y coordinate, r/2 is the x coordinate, and further r/2 is the z coordinate. So what you should really understand is that you are actually this far away, from the axis, from the central axis. This is your distance, which is small r, from the central axis, my dear students. This is your central axis. From the central axis, you are actually small r distance away. And also note this is actually perpendicular. Just think of this r/2 in the z direction, this r/2 in the x direction. Z and x axis are perpendicular. Don't you see this small r is actually the hypotenuse? Do you see that? Are you able to visualize this? Y coordinate is on the top. Okay, r/2 here, r/2 there. So r/2 and r/2 are perpendicular. That blue color line is the hypotenuse. So what is the value of that small r? I think I will need it. It will be root of r/2 square plus r/2 square, which is nothing but r square by 4 plus r square by 4. R square comes outside. 1/4 plus 1/4 is 1/√2. That's it. So that's it. 1/4 plus 1/4 is 1/2. So that is the entire thing under the root. Now the final answer, guys. So whenever you are inside a tube carrying current, the field inside of that is given by mu naught. You have current divided by 2 pi radius of the tube square into small r. Small r happens to be the distance from the axis. Remember, this is the formula for a solid cylinder carrying some current, and you are finding the field inside. When you are outside, the formula is different. This r comes below, and instead of r square, it just becomes small r. I hope you remember these things which were taught to you in your daily classes. So this is as long as r is less than capital R. So just substitute everything. So mu naught by 2 pi. Current, I just keep it as I. R square, keep it as r square. This will be r, and I have by √2. One of the r gets cancelled, so it becomes mu naught I. I have 2√2 pi and r. Just check, where is it? Is it option A? Yes, it is. Yes, it is. Perfecto. Kalyan Ram, my goodness, you are an IIT Roorkee. Thanks to me. Okay, I thank you. I'm so glad that you are, attributing all the success that you have to me and to the channel. But trust me, it's your hard work as well. Okay, and I'm so glad that you trusted all of us in the times of need and in times of necessity. I'm so glad, bacha. Keep doing well. God bless you. God bless you. Okay, so let's move on to another question. So here, the main challenge of this question was visualization. Many people lose out over here in this visualization process. They take small r as r/2. If you take small r as r/2, you will get a wrong answer. Small r is not r/2. r/2 and r/2 are perpendicular, so you have to take the hypotenuse. So you have to think from the axis how far you are. So you're not r by 2 far away, you are r by root 2 distance away. So moving on to another question on your screen. Electromagnetic wave, frequency, moving in z-axis, amplitude is given, epsilon naught is given. What is the average energy density of the electric field? What is the average energy density of the electric field? How many questions? More than 20, bacha. A lot of questions, let me tell you that. Okay, cool. So Rockstar Bhargav, in that cylinder problem, just think of it this way, bacha. Just think of it this way. If you look at the cylinder, from the top, na, this is what you are going to see. This is your z-axis, this is r by 2, this is r by 2. So actually speaking, the magnetic field lines are like this, right? The magnetic field lines inside are always circular. So what do you need is this distance from the axis. So that is small r. These green distances are not relevant. Remember, magnetic field lines are always circular. So that is why you need the distance from the center. That's why I have taken that. I hope that is clear. Rest all is direct application of formula. This is standard formula. You should know it inside. Watch my formula session in case you guys have missed it. Okay, moving on to this question. Over here, what is the average energy density of the field? The energy density of the field is given by half epsilon naught electric field's RMS value square. That is the value of the energy density. ERMS is the average energy that you can take to give the same power or energy over one cycle. So that is why you take RMS value. So RMS of any number, you have seen this in AC also, is the maximum value by root 2. So whole square. So this will become nothing but epsilon naught E naught square by 2 into 2 is nothing but 4. Now you just have to substitute. Epsilon naught is nothing but 8.8 into 10 to the power minus 12. E naught electric field's amplitude, you can see it is 4. So you will put 4 square divided by 4. So my dear students, one of the 4 will get cancelled. So 4 into 8.8 into 10 to the power minus 12. What is 4 into 8.8? 8 4s are 32. So it will be, come on, 32 plus 3.2, that is 35.2. So 35.2 into 10 to the power minus 12. That should be the answer. Yep, joules per meter cube. Always energy density means how much energy is there per meter cube. Per meter cube. That is the meaning of that. Thank you, Pravnisti. I'm so glad you are in NIT Warangal because of me. Thank you so much for acknowledging and coming here and letting other students know. Complete physics video, Karthik VP. I have done it yesterday. Please watch the session from Sunday. Okay, let's move on to the next question coming up on your screen. Standard question of infinite capacitors in series. Ajit Singh Hajari, I'm doing a wonderful job. I'm an engineer working JSW and watching my lectures. By looking at you, sometimes I feel teaching is this much easy. Ajit Singh, well, let's not discredit the fact that just like any other job in the world, teaching is as hard as as many people don't acknowledge or realize. Trust me, it is a very, very hard job. So I mean, anybody can probably teach, but not everybody can become a very good or a great teacher who love and passionately, get themselves involved in the subject as well as the students. So I'm so glad that you two are doing a wonderful job, and we too are trying our best to make sure that many of these kids learn different aspects of life and not just physics, chemistry, maths. So physics, chemistry, maths is just a medium of teaching, that's all. Okay, so let's see how we can do this problem when we have infinite capacitors in series. That's an infinite ladder. Let's try to do this question as well. Now, what I see is whenever I have an infinite ladder, there is some repeating pattern. So if you take away one of the part of that entire ladder, infinite ladder, it does not make any difference to the net effective resistance or the capacitance. In this case, how about just looking at only this much part? And the remaining part, if you look at this part and remove it, whatever is remaining is exact repetition of what is starting from A and B. Look at this, the way it is starting and it is continuing till infinity. If you remove this and if you shift point A and B over here, it looks exactly the same. So this entire thing must have the same equivalent capacitance X. This must have the same equivalent capacitance X as that of this entire circuit. This is C, and this is C. These two are in parallel. So I can just say there is one C over here there is one capacitor over here, one capacitor over here, C and C. When capacitors are in parallel, you just add their capacitance, so C plus X. Now when you combine all of them together, finally you should get only one single capacitance, and that is X. Because that's what I assumed. What was X? X is the capacitance of the entire infinite ladder. So between these 2 points it is X. So when you finally reduce it, you should again get back X. Now if you have understood till here, what I have done, removed the first part which is repeating. The remaining part is exactly the same as this. So the entire structure over here I replace it with X. Now these two are in parallel, so C plus X. Now these three are in series. When you combine it, you again get X. Whenever capacitors are in series, what do? 1 by C1 plus 1 by C2 plus 1 by C3. That's all you have to do. So that's all. So I'll just write over here is equal to 1 by equivalent capacitance. This is what you do for capacitors in series. That's all. 1 by C comes 2 times. So 2 by C plus 1 by C plus X is equal to 1 by X. Cross multiply or take LCM basically. So you'll get 2 times of C plus X plus C divided by C into C plus X is equal to 1 by X. Now take X over here, take these people over here. So it will become 2X into C plus X plus Cx is equal to C into C plus X. Just check this out. Now further open up the brackets. So it will become 2Cx plus 2x square plus Cx is equal to C square plus Cx. Now I can see Cx and Cx is there here as well as here. It gets cancelled. Shift this C square on this side. So I'm just left with 2 or rather first let me put 2x square first. 2x square plus 2c times of x minus c square is equal to 0. You can see it is a clear quadratic equation. Do you see that? This is nothing but a clear quadratic equation. Everybody with me? So just find the roots. So x will be minus b, which is minus 2c, plus or minus root of b square, which is 4c square, minus 4 into a into c. C is nothing but minus c square, so it will become plus c square. Whole thing by 2a, so 2 into 2. So this will finally again become, you can see minus 2c plus or minus, c square will come outside as c. 4 2s are 8, 8 plus 4 is 12, so root of 12 divided by 4. So this will become, see you can take it outside, minus can't be the answer, it will be invalid root. So it will become minus 2c plus, minus is invalid, only plus. So root of 12 is 4 into 3's root. So root of 4 is 2. So 2 root of 3 times of c, whole thing divided by 4. So I think there should be one option somewhere over here. Just check this out. So it will become 2 to cancel. So minus 1 plus root 3, whole thing divided by 2 into c. So do I have it over here? Yes, root 3 minus 1 divided by 2 and into c. I think it is option C, guys. Yeah, it is option C. Perfecto. No, it's not D. Option D has plus over here. Look at this. This is root 3 minus 1. If you rearrange this, this is nothing but going to be root 3 minus 1. That's all. Whole thing divided by 2. Everyone? Hyper Nanny YT6. I'm going to do many questions. I have not counted, bacha, but many questions. On Saturday also I did a short series. In case you have not watched it, for more questions, please watch that. Yesterday I did a formula revision series. Please watch that. Today I'm doing again most expected, most predicted, high weightage questions which you should do at the last minute of preparation. The ratio of the coefficient of volume expansion of glass to that of liquid is 1:4. Coefficient of expansion, volume expansion, gamma, okay, 1:4. The fraction of the inner volume that the container should, what fraction of the inner volume of the container should the liquid occupy so that the volume of the remaining vacant space will be same at all the temperatures? Definitely, Viknesh, I'll be sharing the PDF after the session is over. Now, see, this is what the question actually means. This is your container. This is your container. Okay. And then you have your liquid, which is filling it. Okay. This is your liquid, which is filling it. Now, there is obviously some empty space, which is right over here. This is that empty space. This is that empty space. Okay. So you can see that. What fraction of the inner volume of the container should the liquid occupy so that the volume of the remaining vacant space. So that is basically this vacant space. This vacant space must be same. So this must be basically constant. How can that be constant? Just visualize, think of an equation which satisfies this condition. When you heat, this container expands, liquid also expands, but this volume should remain same. That means how much ever is the expansion of liquid, the same expansion should be for the container. So the net change is zero. Net change is zero. Everybody with me? Everybody with me? Jupudi, join the Telegram channel. That's where you're going to get the PDF, not in the description box, in the Telegram channel. Telegram channel link is there in the description box. Okay, so because that is constant, that just means, my dear students, that just means that the volume change of the container is exactly equal to the volume change of that liquid. Now what is the volume change of the container? It is volume of the container into gamma of the container into delta T. This is equal to volume of the liquid into gamma of the liquid into delta T. You can clearly see from here delta T cancels. So what am I left with is VL, take VC below, is equal to VL by VC. Gamma C remains on the top and gamma L is over here. Now as per the given question, the coefficient of the glass to that of the liquid, glass to the liquid, container to the liquid, gamma is 1:4. So this is already given to be 1:4. So this is volume of the liquid upon volume of the container. This is exactly what is asked. What is a fraction of the container that the liquid should occupy? That's it. That's exactly what has been asked. Liquid occupies 1/4 of the container. Then you will see the empty space remains constant. So if the liquid occupies 1/4 of the container, then the remaining volume remains same even if you heat it or cool it. Everybody with me on this? Everybody with me on this? Understood? Clear? Yep. Let's move on now to the next question coming up on your screen. If the car is moving at speed v, blowing horn, reflected from a large mountain, the apparent frequency heard and beat frequency. How many of you know that this question has come many times in different ways, either value or formula? Sometimes they ask beat frequency, sometimes they ask the frequency heard by the car. So many times these kind of questions have come, you cannot give this question a miss. So imagine this is the car basically going like this, okay, with some speed v towards a large mountain. That means it is a reflector. Always when you see these kind of questions, just imagine there is another car like a mirror image which is going this way, and that is coming with speed v this side, and it is emitting sound of frequency f. It is emitting sound of frequency f. This is now the source, and this guy is now the detector. This guy is now the detector. So this guy will hear the apparent frequency. That is basically the source, like an actual source you can think. So the sound which goes there and comes back, you can think as if it is coming from that side only, as if a mirror reflection is happening. Great. So what is the formula, my dear students? Apparent frequency is nothing but your original frequency into speed of sound plus minus. Here you have the detector speed upon the source speed. In this case, the original frequency is f, c. Detector is going towards the source. So the frequency will increase because of that. So put a plus sign. And the source is also coming towards the detector. Frequency will again increase, but do not put a plus here, put a minus. So whenever you go down for the source, remember it's in the denominator. When you put minus v, denominator decreases, the ratio increases. Denominator decreases, ratio increases. Because source is coming close, frequency goes up. So that's why I put this minus sign. So this is the apparent frequency. So this is the first answer of the problem. The beat frequency will be nothing but the apparent frequency heard minus the original frequency. So apparent frequency will be f naught, and you will have c plus v upon c minus v minus f naught. So f naught is common, and you can write this as c plus v by c minus v minus 1. So delta f will then be, you can just take the LCM, my dear students. C minus v is the LCM. You can see that. So c plus v minus c plus v. That's it. So this will become f naught, c cancels, it will become 2 times v divided by c minus v. So that is your delta f, that is your final beat frequency. That is your final beat frequency. So reflected means don't we multiply with 2? Priya, that is different, that is speed. That is when, imagine if you have a stationary source and a moving mirror like this with you, then the image will move it to you. Here the source is moving with you, the mirror is at rest, then the image will move with you. So the case that you are referring to is when the mirror is moving. So when the mirror is at rest, it is you only. I hope that is clear. Favorite question, Yashashwini? So cool. Okay. Yes, I'll be doing the JEE papers tomorrow, Kshitij. In fact, you would have seen on the channel, it's already probably showing in the upcoming sessions, like I showed you at the beginning of the class as well. Okay. Let's do this. The speed of the projectile at its maximum height is √3/2 times the initial speed. If the range of the projectile is p times the maximum height attained by it, then what is the value of p? Okay, let's try to understand this. The speed of the projectile at maximum height, the speed of the projectile at the maximum height is basically √3/2 times its initial speed. Let's assume that the initial speed is u, this is theta, this is the speed at the maximum height. Don't you remember, in projectile motion the horizontal speed never changes, it's only the vertical speed which becomes smaller, becomes 0 and then becomes negative. So always the horizontal speed remains, and at the topmost point it is only the horizontal speed which is present. Nothing else is present. Nothing else is present. Everyone? Okay. Now what is the relationship between the initial speed and the final speed at the top? Ux is basically u cos theta. Ux is basically u cos theta, and the speed at the maximum height is √3/2 times of u. That is what is given. That is what is given. U cancels, cos theta is √3/2. That means the value of theta that is there, whose cos is √3/2, obviously 30 degrees. So that is the first thing that you get. Now the next thing is, what is the value of p? Now this p is nothing but the ratio of, look at this, range of the projectile and maximum height. Range of the projectile and maximum height. Range of a projectile is u square sine 2 theta divided by g and the height of a projectile is u square sine square theta by 2g. Now you can see u square, g cancels, so I am left with this 2 goes on the top, 2 sine 2 theta divided by sine square theta. Substitute the values. Sine of 2 theta, 2 times 30 is basically 60 upon sine square 30. So my dear students, this is going to be 2. Sine 60 is nothing but √3/2. Sine 30 is nothing but half, so half square. 2 cancels, so I'm just left with √3/1/4. 4 goes on the top, this will become 4√3. That is the value of p that you want. That is the value of p that you want. Let's see whether it is correct or wrong. Yes, it is correct, definitely. There you go. I'm so glad, Likith, you got 90 plus in your physics exam. So cool, so cool. So cool, so cool. Amazing, amazing. Let's move on to another question coming up on your screen, and here it is. A particle executes SHM with a time period of 16 seconds. When time is 2, it is at the mean position. When time is 4, the velocity is 4 meters per second. Then the amplitude of the motion is how much? Let's try to visualize first. Imagine a simple harmonic motion. Okay, when it is crossing the mean position, that time the time is equal to 2 meters per second. Okay, after some time it reaches some point where the time is 4 seconds but the speed is 4 meters per second. So obviously this is V max at the mean position. This should be basically V max at the mean. Here the speed becomes, let's say, 4 meters per second at some value of x. Now if you think about it closely, you will also realize one more thing. Here the time was 2 seconds. Here the time was 2 seconds. Here the time was 4 seconds. Let's reset the time. Let's make this as time 0, because then it will be easy to analyze the situation. If I make this as time 0, then this time will be 2 seconds. This is in the new reference of time. I am changing my reference of time. So let's make t is equal to 0 when it crosses the mean position. Why keep it at 2 seconds? I just need the time interval. Basically the time interval is basically still going to be 2 seconds. So that's all that matters. Everyone with me? Understood? Clear? Awesome. So whether it is 2 and 4 or 5 and 7 or 100 and 102 or 0 and 2 doesn't change anything in the problem. That's what you need to realize. Now we know that x is basically a sine omega t. That's your standard equation of simple harmonic motion. X value I do not know. I think I can find it out, because only through x I think I can find the amplitude. How, you might say? Remember, the formula for velocity is omega root a square minus x square. I know velocity is 4 meters per second. Omega, that also I know, because time period is known. From this value, just imagine time period is known. That means omega will be 2 pi by time period, which is 2 pi by 16, which is just pi by 8. So I know the value of omega also, it is basically pi by 8. The only thing I do not know is basically what is the value of x. If I find x, I think I can find the amplitude. So look over here, x will be equal to a sine omega. Omega is nothing but pi by 8. Time, just take 2 seconds. 2 goes with 8 4 times. So sine of 45 degrees is 1 by root 2. So x is a by root 2. So just put a by root 2's square. So what am I going to get, my dear students? Pi and 8 4s are 32. So 32 is equal to pi and root of a square minus a square by 2. 1 minus half is half. So this will be a square by 2. So this will be pi a by root 2. So that is 32. Correct? Shift root 2 there, shift pi below. So amplitude will be 32 times of root 2 divided by pi. I think that is what is needed. Just check it out. Option D is the correct answer. Yes, 32 root 2 divided by pi. So there was actually a 2 or 3 step problem. What are the main steps? Number 1, to realize that in order to find the speed, I need angular frequency. So angular frequency can be found by time period. But to find that, I also need x. X can be found by this equation, because I know after 2 seconds, it reaches some position where the speed is 4 meters per second. This is the x at which the speed is 4 meters per second. That's all. So I need these 3 concepts to solve the problem. Okay, beautiful question. Let's move to the next one coming up on your screen. Exactly. So a metallic rod of length L is tied to a string of length 2L and is made to rotate with the angular speed omega on a table. Magnetic field is there. What is the EMF induced across the ends of the rod? Now let me remind you guys, whenever you have a rod and you rotate it with angular speed omega, length is L, and it is placed inside a magnetic field, the EMF induced across the rod is half B omega L square. That is the EMF induced. But imagine this, you have only a portion of the rod, and that rod is probably this much distance away. How much distance away? The string's length. What is the length of the string? 2L. 2L distance away. The length of the rod is basically L, and you have been asked what is the voltage difference between these 2 points, assuming the entire thing is rotating with omega, again inside your magnetic field. What is the voltage difference between these 2 ends? The way to solve that is as follows. Treat the potential difference between these 2 points will be potential difference between these 2 points minus potential difference between these 2 points. Look over here. Observe carefully what I am trying to do. Find the voltage difference between these 2 points, length 3L, and voltage difference between these 2 points in green. Whatever is remaining, the difference will be voltage difference between these 2 points. So my dear students, the EMF across that particular rod will be EMF across the rod of length 3L minus EMF across the rod of length 2L. That is how you solve these kind of questions. Now use this formula and you will get the answer. So for 3L, just substitute this L as 3L, that's all. So it will be half B omega 3L whole square. For 2L, just substitute L as 2L, that's all. So minus half B omega 2L whole square. Now let's see what do we get as the answer. So the EMF across the rod will be B omega by 2 is common. Here you will have 3L square, that means 9L square, minus 2L square, that is 4L square. 9 minus 4 is 5. So 5B omega L square by 2. This is the logic to solve these questions. How many of you used to do this question via integration? Raise your hands. That is a lengthy method. This is the best method if you know this formula. So any 2 points you want to find the EMF for a rotating rod in magnetic field, find between these 2 points and find between these 2 points. So their subtraction will give you the answer. As simple as that. Crazy, right? Okay, so you are learning all new methods, new tricks while solving these questions. Here is your next question. Electromagnetic wave in vacuum has has the electric and magnetic field E and B, which are always perpendicular to each other. The direction of polarization is given by X and that of the wave propagation is given by K. Then which of the following is correct? Vivek, nice to see you after a long time, bacha. Thank you for the heart. So we all know that electric and magnetic fields are both present in an electromagnetic wave, something like this. Okay, something like this. All right, there you go. And let's say this is how the wave is traveling. And if this is the direction of this velocity of the light, and this is, let's say, your magnetic field, and let's say this is your electric field wave. We all know electric field cross magnetic field is always parallel to the velocity of light. So the wave propagation is basically k bar. That means that's the direction in which the light is traveling. So that is basically parallel to k bar. That is parallel to k bar. So k bar will be parallel to E cross B. Where is E cross B? I think it is there, here and here. So obviously this option is wrong. Even this option is wrong. Either it will be this or it will be this. Now for the next part, polarization. Remember, polarization is always considered in the direction of the electric field. So this is the direction of polarization. This is the direction of polarization. So if you see it from behind, you will see the electric field going up and down like this. You will see the magnetic field going left and right like this. So when you show the polarization, you will show only the plane of the electric field. So the plane of the electric field is the plane of the polarization. So it should be basically this one, not this one. It's not the magnetic field, it is basically the electric field. Yes, that's the correct answer. Awesome. Everyone with me? Option B. No, it's not option C, Bacha Jeevan. It is option B. Hello Sujay, hello Kiran. Welcome Ashwant. Clear? Understood? Don't make these mistakes. So all these are formulas. You should know the speed of light. Speed of light is parallel to what? All these things are there in electromagnetic waves. Please go through the chapter once more. 100% one question is going to come. The dimensions of the critical speed liquid flowing through the tube are expressed as this. Density, viscosity, radius, everything. What is the value of x, y, z? Dimensional analysis question. So if you notice over here, the velocity of the liquid, critical velocity of the liquid is some constant times eta raised to x, density raised to y, and radius raised to it should be z actually, radius raised to z. Find the values of all these things. Find the values of x, y, and z. That's what the question is. I'll tell you what, I'm not going to do it via dimensional analysis. You can do via dimensional analysis, and you will get the same answer as what I'm going to do in a shortcut way. Do you want to know what the shortcut way is? Then put up the hearts in the chat box. Vishnu Papsula, I'm very good, bacha. Thank you for asking. Do you want to see a shortcut way to do this? Yes or no? Put up some hearts in the chat box. All right, so here is the trick, guys. Do you remember some formula which relates viscosity, speed, radius and density? I think you do. That is the Reynolds number, which is a pure number, no dimensions at all, which is rho Vd, or the diameter, divided by the viscosity. This is a dimensionless number, my dear students. So this is dimensionless is equal to dimension of density, dimension of velocity, dimension of diameter, which is also dimension of length, upon dimension of viscosity. Now basically from this, dimension of velocity will be, this is dimensionless, so just make it eta. Bring this rho below, bring this rho below, bring this diameter below. Obviously now you can write it as dimensions of viscosity, rho's dimension -1, diameter's dimension also -1. It's as good as writing viscosity is raised to 1, density is raised to -1, and diameter or radius, one and the same thing. Diameter is twice the radius, 2 does not have any dimensions, so you can take radius raised to -1. That's it, done. What is the answer? It should be 1, -1 and -1. That's it. Isn't it so simple, guys? Yeah, so this is how you should think in the exam. If you solve it by this method, yes, you'll get the answer, but it will take a lot of time. I mean, imagine 3 equations, 3 unknowns, and then substituting, so many things are there. Here it's so easy, you just need to know which formula is the best suited for that problem. So always try to think of the best suited formula. That's why formulas will help. So these are the situations. 100% guys, there is a good chance that you will get a dimensional analysis question and you will remember me. Hello Aishwarya, nice to see you, bacha. Okay, come on, Kurishi, Loknath, come on, focus on the session. I know you guys are from Hyderabad or Jammu Kashmir or Andaman or Tamil Nadu or I don't know, Bombay, Delhi, doesn't matter guys, focus, answer, because tomorrow onwards the exams are going to start, and tomorrow onwards I'm going to discuss all the papers as well, so you are going to be in a completely different zone altogether after this. Here is the question. A wire of length L, uniform mass density, bent into a circular loop. The moment of inertia of the loop about the axis xx prime is how much? Let's try to do this question, my dear students. In order to do the problem, first I need to know the moment of inertia about this axis. Now this is basically the diametrical axis. Now the moment of inertia about this diameter or even this diameter is going to be the same. Both the diameters are same. In fact, if you add this and this, I get the moment of inertia about this axis, which is basically your standard axis about which you know the moment of inertia. Let's say I call it as IC. Okay, so my dear students, now what you're going to do is use perpendicular axis theorem. And we know that IC is nothing but equal to ID plus ID, basically 2 times of ID. So therefore ID is nothing but, I need ID, is nothing but half of IC. What is the value of IC? Moment of inertia of a ring about this axis, mr square. Standard axis, it is nothing but mr square. So basically ID is mr square by 2. Once I know ID, I shift the axis here by parallel axis theorem. Just like over here, this was perpendicular axis theorem. Now I'm going to use parallel axis theorem. Using that, I know ID plus mr square is moment of inertia about xx prime. So moment of inertia about xx prime will be ID. ID is nothing but mr square by 2, and then this is mr square. So this is going to be 3 by 2 mr square is moment of inertia about xx prime. But neither do I know m nor do I know r. So here is the logic that I'm going to use. The entire length has been bent into a circle. So definitely L is equal to 2 pi r. So r is basically L by 2 pi. That's number 1. Number 2 is basically, after this, the mass is density per unit length into the length of that wire. So mass is density into the length, linear mass density into the length of the loop. Just have to substitute all these things over here and I think you will get the answer. So first thing, as it is 3 by 2, mass I will just put it as rho L, and R square, my dear students, R square, my dear students, will be nothing but L square by 4 and pi square. That's it. Just check this out. Where do you get the answer over here? Just check this out. Where do you get the answer over here? Okay, so check it. Where is it? Option D, right? Option D, yes. 2 4s are 8, L square into L is L cube, rho is there, 3 is there. That's it. You will get the answer. Perfecto. So this will lead to this. Perfect. Great. Awesomeness. So this was the tricky part, because many students get it till here, but they don't know how to convert this. Sometimes students get this and are stuck to which theorem should you use. Directly they use parallel axis, or they forget about perpendicular axis or something like that. So be careful about the theorems. These questions are also highly likely in the exams which are going to follow. Next one coming up on your screen. There is a ball of mass 4 kg moving in a straight line, strikes a ball at rest. After collision, A and B move with speeds v1, v2, making angles 30 and 60 with respect to the original direction. What is the ratio of v1 by v2? I think we should draw the diagram. Without that, we will not understand. So this is the 4 kg block. It is moving with some speed u. It hits another 1 kg block, which is right now at rest. After the collision, what happens is this. This 4 kg block is going to move with v1 speed at an angle of 30 degrees. So this is speed v1 making angle 30 degrees. And the other block which is there, which is of 1 kg, that will move with speed v2 making an angle of 60 degrees. Question is, what is the ratio of v1 by v2 after the collision? So here is what I look. When the mass is moving here, there is no momentum in the y-axis. Here also, after the collision, there should be no momentum in the y-axis. This component and this component should cancel out each other. That's the trick over here, my dear students. If this is the x-axis and this is your y-axis, the net momentum before and after in y-axis is basically going to be the same. So if you notice clearly, before there was no momentum in the y-axis, afterwards also there can't be any momentum. Momentum later on will be mass into speed, but which component? Sine 30 component. This guy's momentum is downward, so I'll put a minus sign. Mass into speed into sine 60 component. Bring these people over here. So it will be v2 sine 60 is equal to 4 v1 sine 30. Now we all know what is sine 30. It is nothing but half. We all know what is sine 60, that is root 3 by 2. We can also see this 2 and this 2 gets cancelled. So what is us? v1 by v2, right? So place v2 below, or just keep root 3 over here and send 4 over here, guys. This will be nothing but v1 by v2. So that should be the answer. Just check it out. Option A. Perfect. v1 by v2 is root 3 by 4. Everyone with me? Johnny, concentrate on what is happening now. To practice these kind of questions and also short questions. And if you have time, just go through the formula sessions and also attend all the discussion classes. That will give you a good idea of what kind of questions are coming. Just do that much. That will give you a lot of marks, trust me. Okay, moving on to the next question. In the given volume temperature graph, P1, P2 are the two pressures for which you are drawing these V versus T graphs. Compare the pressures. Interesting. I think based on ideal gas equation coming to thermodynamics, we all know pressure into volume is basically nRT. So volume versus temperature, right? So volume will be nR by P into T. Now this is just like saying this is your y-axis, this is nothing but your x-axis. Naturally, this is like your slope. Y is equal to mx, straight line. So this is nothing but the slope. So my dear students, the slope over here is n, or rather I would say the slope over here is inversely proportional to the pressure. So which one has more slope? Obviously P2 has more slope. So slope of P2 is more than slope of P1. Because slope is inversely proportional to pressure, the one which has larger slope has smaller pressure. So P2 will be less than P1 because of this. Is that clear? P2 will be less than P1. That's it. That's the answer. Awesomeness. Okay. Okay. Great. Very good. Okay. Moving on to the next question on your screen. This is also very standard question, must do, guys. On magnetism. An iron rod of length L, magnetic moment is bent into a semicircle. What is the new magnetic moment? What is the new magnetic moment? Doleshwar, Yamula, please watch my cheat codes and how to guess, or how to make sure that your guesses are as close as possible. It's there on our channel homepage itself. If you just go down over here, I don't know how many of you have seen this, guess options. That's one thing, how to guess correctly in MCQs. It's also there, and all the strategy videos, everything is there right on the channel. Just check it out later on. Okay, it's up to you when you want to see it. So let's move to this question now. When you have a rod of length L, so there is a pole plus M over here, minus M over here. It will have its own magnetic moment, which is small m into L. This was initially. You bend it into a semicircle. So that means it will look something like this. So now this is your plus M, this is your minus M. Now this is as good as saying there is a magnet. There is a magnet with the north pole here, south pole here. This is minus M, this is your plus M. But this length is the diameter. So the diameter is basically 2r. This is basically the diameter. This is now the new magnetic moment M prime. Because it's a vector quantity, all these vectors, when you add them, you will just go from the start till the end. Magnetic moment is a vector. So just join from here to here. That is the equivalent length of the magnet. Whenever you bend magnets, start from one end to the other end, draw a straight line like displacement. That is the effective length. So 2r over here is basically the effective length of that magnet. So my dear students, M prime will be nothing but pole strength M into 2r. Now how do I find the value of r? That's the challenge. Obviously we know that the length has been bent into semicircle. So this length is actually speaking pi r, the semicircle circumference. So my dear students, r is nothing but L divided by pi. R is nothing but L divided by pi. So just put over here L by pi. But small m into L is nothing but capital M into 2 divided by pi. So that is the new magnetic moment. Yes, 2m by pi. That's the correct answer. Perfecto. Everyone got it? How we got this question? So this length is the circumference. The length of the rod, so I'm just mentioning it over here. The length of the rod is basically nothing but the circumference of semicircle. Semicircle is not 2 pi r, it is just pi r. Don't put that 2 or else you'll get a wrong answer then. That is one of the most common mistakes. Moving on to another question coming up on your screen. Here it is. Paper solving session will be obviously tomorrow after the paper. If you want me to do it before the paper, I'll do that also. Okay. So yes guys, paper solving session before the paper starts. Paper leaked. So here is the another question, common question. There is a square loop carrying current at the center. Find the magnetic field. Find the magnetic field at the center. Here is what I think. Just find the magnetic field due to any one of them over here. Multiplied 4 times. This. Each one will produce magnetic field. They will all add and it will give you 4 times the magnetic field. Thank you Yashasri. Thank you so much bacha. So the magnetic field due to any one side will be given by the formula mu naught I by 4 pi r, and here you have sine of alpha plus sine of beta. That is the standard form. So mu naught by 4 pi is common. I is also there. What is r over here? Think about it. This is basically your r. this is basically your R. If this whole thing is L, this is L by 2, L by 2, L by 2, L by 2. So basically R is nothing but L by 2. R is nothing but L by 2. Next up is what is sine alpha and sine beta. This angle and this angle. Obviously, this is going to be a right angled isosceles triangle. This is also equal to this side. So guys, this is a right angled isosceles triangle. That means this should be 45 degrees. Even this should be 45 degrees. I hope you know why this is equal, because this is also L by 2, this is also L by 2. So obviously this will be 45, this is 45, this is 45. This is an isosceles right angle triangle. So hence it will be nothing but sine 45 plus sine 45. This is the formula. Let's try to solve this now. Mu naught by 4 pi, and here you have 2I by L. This 2 goes on the top. Sine 45 plus sine 45 is 2 times of 1 by root 2. Okay, so that will make it this 2 and this 2 with this 4 will cancel. So you will have mu naught I, L is there, pi is there, and root 2 is there. So pi root 2 into L. That is the magnetic field due to any one side. So the net magnetic field will be 4 times the magnetic field due to any one side, because there are 4 sides. So that will become 4 mu naught I divided by pi root 2 times of L. That should be the answer. Everyone with me? Sir, I need any QP. What is the meaning of QP? Yeah? I don't know your short forms. Is that clear? Everybody got it? Put up a thumbs up. And have you smashed the like button? Yep. Very good. AP Gamer and so many others. Ria, Ashwarya. Yes. So common question. Sometimes they can ask you for a triangle. Practice all these things. Don't think, sir, sure shot you told. No. Sir, in the exam they asked triangle, sir. You told only square. I didn't do triangle. Arey, guys, understand. These are the models of the question. So just because I told you this, don't solve only this. Solve triangle, solve for maybe circle. So try these 2-3 things, then you will get an idea. Same thing for other things also, whatever I am teaching over here. Okay, maybe instead of a semicircle, maybe they make a triangle, or maybe they make a side of a square, who knows, or maybe they make a L-shaped joint. So try all these things. That's when you will not make mistakes. When is the start of the April attempt? Janani, immediately after your first attempt. But we'll do little bit of boards also, we'll do little bit of EMSAT also, we will do little bit of advanced also, we'll do little bit of mains also. So all the things are going to come up. And let me tell you, the channel is getting a big makeover, and you would have seen the last few days how we are continuously pushing ourselves to do lots and lots of things, lots and lots of lectures for you guys. So this channel is going to go to really great heights. So make sure you stay tuned on the channel by hitting the subscribe button. And yes, smash the like button so that YouTube pushes our videos on the top of your feed while you watch YouTube. Okay, that's how the algorithm works. So the BH curves for A and B shown below are associated with is a pure theory based question. Guys, we know for a transformer you use a soft iron core, not a steel core, because of the hysteresis losses. So for the hysteresis losses, you check the area. The loss is less. The loss is going to be less. Not just that, you will see that it can be easily reversed in magnetic field. So basically that point which is over here, this distance, this is basically going to tell you how easy it is to reverse the magnetic field. Okay, so basically that is also called as the coercivity. So the coercivity is also less. For whom? For soft iron. It can be very easily demagnetized and magnetized in the opposite direction. So that is why soft iron and steel respectively. Moving on to the next question. Definitely, Arman Sheikh, that's a very good thought. What you're doing, very good. Keep up all the backup options as much as possible. You should give all the exams, plus it will act like a practice. In the semiconductor, electrons is this much, holes is this much. Guys, you can clearly see the number of electrons is more than number of holes. Obviously, which type of semiconductor? It should be N-type semiconductor. Obviously, it can't be P-type semiconductor. So either it is this or it is this. Now, how to get to this answer? The question says find the resistivity. Now resistivity is 1 by conductivity, and conductivity for a semiconductor is electron charge into mu E into what do you say, Ne plus mu H into NH. So that is the formula. Just have to substitute everything that you know. Electron charge is 1.6 into 10 to the power minus 19. Mobility of electron is 2.3. Number of electrons is how much? 8 into 10 to the power 18. 8 into 10 to the power 18 plus mobility of holes is 0.01 into number of holes is 5 into 10 to the power 18. 5 into 10 to the power 18. That's all. Do the math and I think you will get the answer. Okay. So you just check it out. The calculations and all that, I'm just leaving it up to you. So most likely it should come out to be 0.34 ohm meter. Okay, QP means question paper. Oh my god. Just waves question is also coming. Yep. I think I also did one Doppler effect based question sometime back. Yep. Sai Sanjay, you are very late, but it's okay. Just watch the replay later on. For now, continue with the part which is going on. Okay, great. Moving on to the next question. By the way, waves is sure short, but it is not high weightage, I would say. You'll get one question, guarantee, on waves. Okay, let's see how many of you can do this question. Fun question, logic gates. Guarantee you will get marks in here. Yep. Yes, Nishu, what question paper? What do you want me to do about question paper? Will I discuss the sessions question paper? Yes, Arun. We are going to do 24th, that's tomorrow, 25th sessions, and then there is a break. Then directly we'll go to 30, 31 and all that question papers discussion. Definitely we are doing the question papers. HoD JEE question paper with answer. Nishu, you can check out the playlist. Last few years, whatever sessions have happened, whichever question papers we have discussed, it's there in the playlist. Advanced, mains, even bit sat questions are there. You can use it for mains also. Even I have done for EM sat and other examinations. Just check down, it will be there somewhere or in the strategy playlist or somewhere. Okay, let's see. Will questions repeat? Arul, yes, there are good chances that the many questions will repeat. Maybe not exactly, maybe they will change the values here and there. But I have seen in the last 2-3 years, questions are getting repeated. Okay, expect in every subject, at least in physics, I can say 2-3 questions will get repeated. Okay, so let's see guys, what do we do over here? If A is 0, B is also 0, then this is 0, okay, and this is 1 because this is a NOT gate. Okay, because this same 0 will come over here, this will become NOT. So B will go over here 0. Oops, wait a minute, I'll just put everything on the top. This will be 0, and because this is 0, this will be 1. 0 and 1 is 0. 1 and 0 is 0. 0 or 0 is 0. So the answer is 0. So where is 0? Okay, it's either this or this. Next, when A is 1, B is 1. So A is 1, so here. And 1's negation will be 0. Okay, B is 1, so coming here, B's negation is 0. 1 and 0, 0. 0 and 1, 0. 0 and 0 is also 0. So where is 0 again? It's over here. That's it. That's the answer. I will definitely say all the best if you wait till the end, Sunita. Okay, I'm going to give you a small tip and advice towards the end. So you have to wait till the end. Only then I'll give you that motivation and those tips. Okay, moving on to the next question. Ready, my warriors? Okay, a common emitter amplifier using the output resistance 5000, input resistance 2000, input signal this much, beta this much, calculate the output voltage. The moment many students see this question, they just leave it thinking, oh my god, transistor. But trust me, this is such an easy question. See guys, it's simple. Voltage gain is basically current gain multiplied by resistance gain. So what is the meaning of this current gain? It is basically this beta. Resistance gain means output resistance by input resistance. Voltage gain means output voltage by input voltage. There is also output current by input current, which is basically called as beta. Alpha, beta parameters are there. Now just substitute the values. Output voltage I do not know. Input voltage is 10 millivolts. So this is 10 millivolts. This is also V0 millivolts is equal to beta 50 into R0 by Ri. Output is 5000, input is 2000. 5000 divided by 2000. Let's see what and all gets cancelled. 0, 0, 0, 0, 0, 0. Okay, so take these people over here. So let's see what do we get. So V naught, this millivolt and millivolt gets cancelled. So this will become basically 50 into 5 into 10 divided by 2. So guys, 5 5s are 25. 25 divided by 2, 12.5. So this is just going to be 1250 millivolts, which is in this case 1.25 volts. 1.25 volts. Just check it. Where is it? Option A, is it? Yes, it is option A. There you go. Done, done. Nishu, first time attending JEE Mains, great. So you just need to practice a little bit more papers. It's okay. You can give this attempt as a preparation or mock test, and maybe by the second attempt you will watch more of my classes and improve your scores. I'm telling you, if you're watching even my YouTube channel out here, I can tell you, you can reach into IIT. And you just saw sometime back many students from IIT Roorkee, IIT, before this even IIT Bombay students have come, and NIT Nagpur and NIT Surathkal and NIT Warangal and NIT Trichy. So many students have kept coming on in our chat box, and they have been telling, okay, we are from this channel and we enjoyed and we learned, and now we are in this NIT, this IIT, this bits. So I'm pretty sure you too will say the same thing, just even watching my lectures and following my strategies. Have that faith. Moving on to the next one coming up on your screen. Two radioactive materials A and B have decay constants 10 lambda lambda. If initially they have the same number of nuclei, then the ratio of the number of nuclei of A and B will be 1 by E after how much time? After how much time? Recent gamer, there is a Hindi channel separate, this is an English channel, okay? So we'll be using pure English, and my English is very simple. It's not like Shashi Tharoor or anyone or Shakespeare. Okay, so here it comes. What is the time after which the final number of nuclei ratio will be 1 by E? So number of nuclei of A will be initial nuclei e to the power, A has a decay constant, of 10 lambda. So e to the power minus 10 lambda t. That is for the first one. For the second one, NB will be, they have the same number of nuclei initially. So N naught, so for B, e to the power minus, what is the decay constant? Lambda. So minus lambda t. Everyone with me? Definitely, Aisha, I'm so glad you're saying that, and I'm really hoping that I get to see all of you guys soon. Not just in this chat box, but also for the celebrations. Now, NA by NB, if I do, it's clearly mentioned it is 1 by E. So this is basically 1 by E. N naught cancels. So e to the power minus 10 lambda t upon e to the power minus lambda t. Bring this on the top, it will be e raised to minus 1 is e raised to minus 10 lambda t plus lambda t, because negative power becomes positive. So this will become e to the power minus 9 lambda t is e raised to minus 1. Don't you see, comparing the powers, minus 1 is minus 9 lambda t, comparing, just compare the powers. Obviously they should be equal because LHS is equal to RHS, minus minus cancels. So 9 lambda into t is equal to 1. So t is equal to 1 by 9 lambda. Where is it? Where is it? Option A, of course. Awesome. Yes, Aishwarya is also going to come. When will the EMSET exam be conducted? Most likely in May, June, bacha, not before that. There's a lot of time. I'm so glad, Nishu. Same here. Great. So I have some homework questions for all of you. Here's the first homework question for all of you kids. You're going to post up the answers in the comment section. These are extra bonus questions. Sure shot, most expected, very likely, predicted questions which are going to come, guys. And this is your second question which you're going to post up in the comment section. Answers, solutions, everything in the Telegram channel. Where do you find the Telegram channel? In the description. Okay, there is a link. You're going to open that up. And what else you need to do? Show your thanks. Say, I enjoyed the class. Sir, I loved the class. Sir, I learned this. Sir, I'm going to do this. Or whatever you feel. Or maybe just put up a heart or just put up a smiley. I would be very, very happy. And do not forget to like. Okay, now certain special tips that I would love to give all of you kids, because you guys are waiting for, my part where I actually tell you what you're going to do in the days to come, just before the exam. Number one tip, guys, make sure that your body clock is tuned. So sleep on time and get up on time. Do not sleep more or sleep less. Do not eat more or eat less. Stay or keep yourself active during the time when you are actually going to give the exam. Number two, remember that you cannot learn new things in the last few days. So whatever you have not done, forget it. This is the first attempt. You are going to get a chance to improve. I know you might say, sir, others will also improve, but that's another story. But the point is, whatever you have learned, just make sure you know that properly. Just revise the formulas. Don't learn new things. Don't do very difficult things. Okay? Just learn whatever you know. Number 3, in the exam, don't look what others are doing. If you feel that the question is wrong, just do not waste the time on the question, move on. Because if the question is for bonus or it is wrong, everybody is going to get bonus even if you do not attempt it. So you are going to save time and you are going to anyways get the marks if you feel the answer is wrong or the question is wrong. Okay? And next thing, whenever you solve the paper, remember, try to analyze and get a feeling. Oh, sir, the maths paper is difficult. Sir, the physics paper is easy. Oh, sir, chemistry, so many things unknown. See, whatever happens to you is going to happen for everyone. So if the paper is difficult, don't get scared. Don't get scared. Think, oh, it's difficult for everyone. Let me go to the easy part. So maths is difficult. Let me see which questions are easy. Just browse, click next, and go to maybe chemistry or physics part. Oh, physics is difficult. Go to this part. So try to do the easy things first. Last tip for all of you. Make sure that whenever you start the first few questions, you try to boost up your confidence in the first 10 minutes. So it's generally said that if you are confident in the first 10 minutes, most likely your entire paper will go well. So make sure that you actually choose wisely the set of questions that you want to start at the beginning. Is that clear? So that's when you build the confidence. Oh, I got first 4 or 5 questions correct in the first 10 minutes. Oh, 5 into 4, 20 marks in my pocket within 5 minutes, guys, 10 minutes. So move on to the next questions. So that's how you're going to slowly gain confidence and you will not blank out or you will not feel strange or weird or nervous in the exam. Is that clear, everybody? Everybody ready to rock? Everybody ready to rock tomorrow? Okay, I know some of you might be having the exams after a few more days. Everybody should come tomorrow for the paper discussion in the afternoon and in the evening also. Okay, do not miss this chance. Your channel, guys, this is your channel. This is not my channel. This is rather, it's not even yours, it's our channel. Think of it that way. Okay, so we have to come back to this channel. We have to show tremendous strength. Get your juniors also, get your classmates also. We're going to discuss the paper. All the best. Stay safe, stay healthy. My best wishes to all the JEE English students and all the Vedantu students and even every student out there. Doesn't matter. Even if you're not enrolled in Vedantu, it doesn't matter. You are my student. You have been watching me. That's all. That's what I care about. Okay. So thank you very much. Have a wonderful evening. Have your lovely dinner. Talk to your parents. Stay positive. And I'm going to see you on the other side. This is Captain Shreyas signing off. Hasta la vista.